Hello, I am Carlos, one of the developers of the Walnut. In this video, aimed to our beta users, I'm going to explain how to create and edit visualizations. I'm going to use an existing simulation of the tic-tac-toe world. So this is our visualization interface. To the right, we have a configurable table showing the trace step by step. And to the left, we have our visualization definition area. As I click here, the visualize button, this definition will be evaluated every time and the result is rendered, replacing the editor. So I'll go back to the editor. So now, what can we write here? Well, our visualization definition language provides a way to describe visual elements that must be rendered in this visualization area. The current version of this language is mainly focused on grids, but if you explore a little bit the contents of the site, you will see that pretty amazing things can be done. In any case, these visual components are described in the documentation. And this will include grids and the grid cells and sprites or images, polylines, and all these components are described in terms of their attributes. So I will go back to our visualization. So in this example, which is the default empty visualization, we have a text element with a label component. The text component with a label attribute, and this attribute will determine the text that must be shown. Okay. So you see, as I modify the attribute, the new visualization is rendered. So each visual component has got its own set of attributes. Some of them are general and some are particular or specific. For example, the label attribute is specific for the text component. So what kind of expressions can we write here that will define the value of these attributes? So these expressions will be expressions in our Walnut core language, which is also fully described in the documentation, and it is no different from many other programming languages. So you should get used to it pretty soon. The idea is that these expressions will be evaluated in a specific context, that this context contains all the trace or simulation information in every step of the simulation. So one easy way to see or to explore what's in the context currently is using this console tool. The console, we can write expressions here and it will give me the result immediately. So at this point, being on on step 0, the state, for example, is an empty list of tokens. But as I go to step 6, I can see that the state has got these 5 tokens. Okay, remember this is a tic-tac-toe game. So this console will help me explore what's in the context and what things I'll be able to use in my visualizations. Okay, you can see that I can write all these complex expressions here, and they will be evaluated. So these sort of expressions are the kind of things we can write then in for our attributes. Okay. So let's create a visualization for our tic-tac-toe game. Okay. So first, let me just create a title here. Okay, so this is going to be my title. So I want it to be located on top of the screen. So I'm gonna use my cheat sheet here. Okay, so what I did is, to this text component, I said, okay, you will be horizontally aligned in the middle of this of your container, and you will vertically aligned on top. Okay, you will see all this positioning system is also described in the documentation. So now below this title I want to create a grid. Okay, so again I'm going to go to my cheat sheet, and so I'm going to write this grid, which is going to use 90% of the space, so I don't go over the title. And this grid, you can see I have some constant attributes, like the background color is white and the inner lines will be black, and I can make them thicker or thinner or whatever. Okay, and I don't want the borders to be visible, but I could have borders also. And then we have this dimension attribute, which is depending on the configuration. So the configuration is part of the world definition, and you can see here in the console the configuration is a dictionary, and I have a grid size attribute or field, which is a pair telling me the dimension of the board. I can always, of course, just use it as a constant value, or we could even have something different here. So as I define the grid, now I want to draw the tokens on top of this, because you can see our state have got some tokens that must be played. So to do that, I'm gonna create nested components here. So I'm gonna create text components for each token in the state. This is an example of creating visual elements by comprehension. So for each token in the state, a text element will be rendered, and this this is gonna depend on the state. So on each step we're gonna have a different number of tokens. Okay, so I'm gonna define the attributes for this text. So the label of the text will be the label of the token, and the position, the x, y coordinates within the grid are gonna be it's gonna be the position defined for the token. So if you see now, each step will render its tokens. Okay, and we can also change. Let's say that's text. It's kind of boring. Okay, so I wanna actually draw something or put an image here. So something else that we can do is to define a sprite for each token in the state. A sprite, it's an image. Okay, so I'm gonna be using here, as I didn't load any sprites yet, I'm gonna be using just some emoji codes. Okay, so let me define the attributes for these sprites. So here I'm using a conditional expression saying that if the token label is X, then use a red circle, otherwise use a blue circle. Okay, this is a conditional expression that will take different values in each state and will give me a value for this attribute, for the image attribute, and the value will be a string that I can then, it will be converted to an emoji, to drawing, and the position of this sprite will depend on the token, and I will make it a bit smaller, like 90% of its container, and I'm giving it some, okay, this is not necessary right now. So you see now I have tokens. Okay, But yeah, I don't remember if the X player was blue or was red. So I still have this text here, but it's being covered by the sprites because the order in which you define the visual components, it creates like a stack of things which will be one on top of each other. So in this case, I will add this opacity to my sprites. Opacity is this alpha component, transparency factor, you see. So now my sprites are a bit transparent and I can see the text behind them. Okay, maybe 5 is too much, so I can play with these values until I think it's good enough. Or maybe I say, okay, no, I just want them to be like this, so I can move the text on top of the sprites. So basically this is how you write and how you define your visualizations. You have the documentation for more formal and complete definition of the attributes and the kind of expressions that define them. So this is all for now. You can contact us if you have any doubt. You will see, you can find us in Twitter at thewalnut.io. And you can find us in our IRC channels, which is hash sign the walnut, and you have our chat window here. This is a very quick way to get in touch with us. So we'll be glad to hear from you with any kind of feedback, but also if you need any help creating these visualizations, or if you want us to kind of guide you step by step and do something with you, we'll be happy to help.